We'll be good, guys. Don't worry. All right, 6.1, guys. And there's some trig proofs. First thing we have to do is jot down most of the identities that you're going to use in your proofs. And then we'll actually try them in proofs. Proofs, yes. You'll be okay, I promise. We spent 3 full days just on the proof part of this, okay? All right, first type of... All right, reciprocal identities. That's our first kind of identity. So sine of theta is equal to 1 over cosec, meaning they are reciprocals of each other. The other way you could write this is that cosecant is equal to 1 over sine. Hopefully that's familiar to you. You guys know that sine and cosecant are reciprocals of each other. We remember that from, well, skill 4 and skill 5. Yeah, okay. Been doing that for a while. So the next one here, I'm going to write cosine of theta. And yes, you need to be writing the theta in all of these, okay? 0 with a line through it, yeah. What do you think cosine is going to be equal to?
1 over sine.
Yes, 1 over secant. And then over here, secant of theta would be equal to, yep, 1 over cosine. And then tangent, 1 over, good. And so cotangent would be equal to 1 over tangent. All right. So that's your first group of identities. You kind of knew those already, right? That's confirmed. I know this first part isn't real exciting. I'm just going to get the identities written down and then we'll do some proofs. Next group is your quotient identities. There's only 2 of these. First one's going to be for tangent. So we already did tangents 1 over cotangent. We're not going to write that again. Let's think back to like your triangles or your unit circle. What was tangent? What over what? Y over x. Okay. Is y sine or cosine? Okay, and x is, so tangent is sine over cosine. Your other quotient identity is for cotangent. What do we think cotangent is going to be? Yes, cosine over sine. Okay, those are your quotient identities. So far, so good. Do you have questions? Julian, do you have questions? Okay. All right, the last group is called the Pythagorean identities. This is the biggest group. All right, I've drawn this little circle over here for a reason. Put a little triangle in there. There's theta by the origin, x, y, and r. Give you a second to get caught up on that. Those labels are familiar, right? We're used to labeling triangles like this. Okay. So looking at that triangle, what would you say for the Pythagorean theorem? Yeah. That's familiar to all of us, right? Okay. We are going to turn that into sines and cosines. So what is x? Cosine. It's x squared, so I'm going to say cosine squared. It's kind of weird the way we write it. You'll get used to it very quickly, but it looks strange at first. You put the square right after the cosine and then the theta. That way you don't confuse it with squaring the theta. We're not squaring the angle, we're squaring the whole thing, okay? Instead of y squared, what am I going to put? Sine squared theta. Okay, if we're talking about the unit circle, what is r? No. 1. Yeah, how long is the radius in the unit circle? 1. So 1 squared is 1. Okay, so this is your original Pythagorean identity. We're going to find 8 other identities just from that one identity, okay? I know, sounds like a lot. It's not that bad, but once we start to get that. But everybody's okay with the first one? You see where it comes from? Okay. And just like the Pythagorean theorem, where the sides would have to be squared, the cosine has to be squared, the sine has to be squared. It doesn't work otherwise, okay? All right, looking at that one, what if I wanted to solve for cosine squared? What would it equal if we're just moving stuff around? 1 minus sine squared, yeah. So that is technically another identity. What you do with these is you use them as substitutions. So if I have cosine squared in my proof, it might be helpful to substitute in 1 minus sine squared. Okay, so we're just kind of going through all the different possible substitutions you could create from this. Okay. All right, again, going back to the original one, what if I solved it for sine squared theta? What would that equal? Okay. All right, so there's your first sort of group. Six more to go, guys. All right, again, let's go back to this cosine squared theta plus sine squared theta equals 1. I'm just starting over with that original one. That's where they all come from. We're going to divide everything by cosine squared theta. Since I'm dividing all terms by it, it's not actually changing the value. Like, I'm not breaking any rules here. And then we're going to simplify. Okay, 30 seconds. Yeah. Thank you. All right. So guys, what is cosine squared over cosine squared? 1. Okay. What is sine squared over cosine squared? Okay, and sine over cosine is tangent, so this is tangent squared. Yep. Good job, guys. What about 1 over cosine squared? Secant squared, yes. Okay, so that is your next sort of main Pythagorean identity. What do you think I'm going to do from here? Okay, yes. Next, what am I going to do with what's in the red box here? Yeah, solve for like the other stuff. Yeah, what if I solve for 1? What is 1 going to equal? Yeah. Secant squared theta minus. Do you see it? Just moving it over? And then go back to the original. What if I solve for tangent squared? What will that equal? Secant squared theta minus 1. Good. You with me so far? Okay. Okay, Krish, now what are we going to do? Yes. Divide by sine squared. So again, write the original one, cosine squared theta plus sine squared theta equals 1. Divide them all by sine squared theta. All right, guys, try to simplify it for me. What do we get? Hold on. Yeah, what's 1 over sine squared? Not cosecant of 2 theta. That's a very different thing than saying the power of 2 squared. Cosecant squared theta. There we go. And can we move things around? Yes, we can. All right, what does cotangent squared theta equal? And what does 1 equal? All right, so many identities. If you know the first one, you could find the rest of them, right? Okay. The better that you know these, the easier the proofs are because you just recognize things much more quickly. You'll see like shorter paths through the proofs. If you don't recognize them, you can usually still get there, but it's a much longer problem. So knowing these just makes it easier. Any questions before we actually try some proofs? Okay. Sine of theta times cotangent of theta equals cosine of theta. We are going to prove that. I'm going to help you with the first one. We're going to jot down a few rules for doing proofs over here as well. Your first rule is that you cannot cross the equal sign. What that's talking about is the properties of equality, like being able to add 2 to both sides or divide everything by 2. You can no longer use those, okay? Those are properties of equality. We don't know these are equal yet. We have to prove that they are. I will only give you proofs that are equal, like they will work. I won't give you ones that don't work. But you can't use, like you can't add things to both sides when you're doing this, okay? You work on one side, simplify it, turn it into the other side, okay? Second one, work vertically. Vertically. So you should work down your page, like you should have a step, and then below it is the next step, and below that is the next step. No like sideways business with arrows and just craziness going on. Work in an organized manner down your page. The neater it is, the easier it is for me to grade it and see what you're doing, which is good for you, okay?
It's like an actual math rule.
No, it is an actual math rule because every step has to be equivalent to the previous step in a proof. And if you're working sideways, that's not equivalent. Like you need to work down with an equal sign. You need to show all steps. I've told you that the proofs all work. So the final step of proof number 1 is going to be cosine of theta equals cosine of theta. You can't just write that and go, okay, I got my proof done. Like that's not how this is. Your work is what I'm actually grading. Okay? So you have to show how did you get there, show all the steps.
So the answer is hard to get is stuff in the middle that's
Right.
what you're asking.
Yeah, so you usually know, like, oh, I got this proof, or I messed that one up. Like, you know, like, oh, hey, I got them to match. So, it's nice. You know where you're going. And then the last one is please just try something, okay? Don't sit and stare. It's not just going to magically come to you what you should do. Try something. If you make a mistake, great. Maybe it led you to something else. It's okay if you mess up. Just go back and try it again. But just staring, you're not going to get better at them if you don't ever write anything down. All right, let's do the first one together so I can show you what all these rules are talking about. So I like to draw a line kind of under the equal sign just to remind me, all right, keep your sides separate, stay in your lane here, work on each side. And you guys can actually do work on both sides to make them match. In honors, I make them only work on one side. And sometimes that's a lot more work than actually simplifying both sides. So you only need one side for the first proof here. Sine of theta, I'm just going to leave alone. But cotangent of theta, what could I write that as? Cosine over sine. Good. You can put your first sine over 1 if that makes you feel better, so that you can see the fraction. And then what's going to happen here? What do you mean by cross multiply?
I know I saw two
Okay. Okay. Yeah, so the numerator of 1 will cancel with the denominator of the other. Cross multiplying usually means like across an equal sign. Okay. Just cancel. All right, so cosine of theta equals cosine of theta. You're done. Okay, a basic one to start with, but the general idea is the same for all of these. All right, let's try another one. Cotangent of theta times secant of theta equals cosecant theta. You guys try this one. Try it on your own, then talk with your neighbor. Did you get there? Check in with each other. Did you get it? You got it, Tyler? Yes? Okay. Nice. Got it? Do you guys agree? Once Aiden's still working. All right, guys, did we get it?
Almost.
Almost? You need a second? Okay, almost. Get it? All right, guys, I would try rewriting as sines and cosines again. So how could I write cotangent?
Do we have to put theta for every single time?
You do, yeah. And then secant, what is that going to be? What happens? Those are gone. I am left with 1 over sine of theta. You have the option of turning cosecant into 1 over sine on the right side, or you can just say cosecant equals cosecant. Either way is fine. Just make sure your sides match. Make them actually be equal. Did we get it? Raise your hand if you got it. Yes? Did you get there? Okay, good. All right, let's try again. They will get a little trickier than these two, but it's good to start simple, right? Yeah. All right, let's do tangent of theta over cosecant of theta equals secant of theta minus cosine of theta. I'll let you guys try. This one's definitely trickier. I would work on both sides of this one probably. You're going to need common denominators. You might need a Pythagorean identity. So we've stepped up a little here. Work together, guys. If you're stuck, talk to each other. Never has to sit and stare. You can't do any. You can't rewrite tangent or something. You don't rewrite cosecant or something. Try something. You will never get there if you just stare at it. Okay. So maybe you're
Why would you be a single dog? Can you still cross an eye with sign? This is how the equation things like that. I know.
Even though you keep it like this, you feel like over.
I'm not trying to keep it. Fraction.
I think the right side is secant. What is secant?
Okay. Now. So 10 over
Exactly. What is it?
Exactly.
Oh, dude, I started learning. He changed it. He changed it.
That's this way.
Oh,
Yeah. Okay. All right, guys, let's go through it.
That's what I was thinking.
Okay, hopefully we tried a few things. I would rewrite it all with sines and cosines, okay? So tangent, I'm going to rewrite as sine of theta over cosine theta. What could I rewrite cosecant as? 1 over sine, okay? I'm going to keep going on this side here for a little while. Fraction divided by a fraction, what do I do? Okay.
I don't remember that though.
Why don't you remember that?
I don't remember that. What is keep change?
Multiply by the reciprocal.
don't remember.
Did you know? Keep the same.
When you change the sign.
I know this with the other.
Dude, you
Oh,
can't just
oh,
tell
that's
us.
just-
I'm not gonna understand.
Okay. So anyway, once we multiply, what is sine times sine? Okay. Now, you could keep going on this side and get to what's on the right side. I'm going to stop here on the left side and start working on the right side. It's a little bit easier than continuing on here. Secant. What could I rewrite secant as? Yes, 1 over cosine. And then cosine over 1.
You can't.
Are you okay with that? No, they're not multiplied, so you can't cross them out. What we need is a common denominator. What is our common denominator going to be? Cosine.
So keep it so it's like
So the first fraction, the 1, is just going to stay there. What we're doing in the second fraction is taking numerator and denominator times cosine. Okay, that's just a fancy way of writing 1. I didn't change the value. I multiplied by 1. I'm turning it into something I can work with. So what is that second numerator going to be? Yes. Okay, let me stop there. The common denominator part seems to be the hardest for everybody today. So.
Numerator, division, denominator. Just
Oh.
Okay.
Bro.
Anytime you see a squared, like I've got 1 minus cosine squared, probably going to need a Pythagorean identity from there. Okay, not always, but usually if it's something squared, that's what you should look for.
Wait, how do you go from secant minus cos to the second step to the third step? I got it.
So you're okay that secant's 1 over cosine?
Yeah.
Okay, then I found a common denominator. Like, think if I had like 3/4 minus 1/4. Sorry, 4 over 1. Let's change that. How would I subtract those? Okay, so in mine, what did I multiply the right one by? Cosine, yes. That's how the numerator became cosine squared.
Oh, and
You see it?
yeah.
Okay.
I didn't know we could do that.
That is called finding a common denominator. All right, Pythagorean identity. What is 1 minus cosine squared equivalent to? Sine squared. And then you're done. Okay. It's like magic, right? Yay! They're like fun when you get them, right? Yay! I was gonna say there's no graphs involved. No graphing in Skill 6, guys. Happy day. So Pythagorean identities. Do you see right here? 1 minus cosine squared. What does that equal? Yeah. That's what you're doing with all of these, is just substituting. Okay, guys. Let's try again. Let's see, let's do. Sine squared theta plus cosine squared theta plus tangent squared theta equals secant squared theta. Looks scary. It's like a 2-step proof, guys.
Are you ready us to go over time?
You guys try. Oh, yes, you can. Got it, James?
Yep,
See? See? Maddie's like, I don't see. 2 steps. You can do it. 2. It's like name that tune. I can do that proof in 2 steps. It's all Pythagorean identities.
It's like you have to remember these rules.
You do. We're spending 3 days on just this stuff. Well,
How would you do this if you didn't know
yeah, you'd rewrite tangent squared as sine squared over cosine squared, and then you'd like find common denominators, but it'd be real messy.
Nice.
Yeah, they make your life easier if you know them. Yes.
When do the twin quizzes go in and
End of the quarter, I'm gonna put something in with those and your unit circle quiz. Tomorrow I'll try to I'll put it in as not for grading in case anyone's forgotten if they did okay or not on their unit circle quiz, because you can still come in and just redo that until you do okay. You did, yes, you did. Not right at this moment. All right, guys, are we ready? Or not quite? Okay, what is sine squared plus cosine squared?
1?
Yeah, so I can replace those 2 things with 1.
Oh my god.
I know.
Now I see it.
Oh, interesting. Yeah, you can still get there in 2 steps. Yeah. All right, and then it's 1 plus tangent squared. My 1 is covered up there, but what is 1 plus tangent squared? There you go. Okay. Keep going. We'll do 1 or 2 more together, okay? Look at your Pythagorean identity. We found it earlier, I promise. Sorry guys, I'm picking which one I want to have you do. That's just to remind you not to move things to that side. It doesn't matter if you draw it or not, it's just to help you. Let's try this one. Cosecant of theta minus sine of theta.
You really know that because of the percentage. Could you actually
Get there?
get on
You could turn tangent squared into sine squared over cosine squared, and then find common denominators with your 1, and then use that sine squared plus cosine squared equals 1. You could get there in 4 more steps if you did it that way.
the identities are kind of
That's why if you know them, it just makes these easier. You can get there without knowing most of them, but it's a lot harder. Am I giving you the same one I just gave you? Yep. All right, try that one, guys. Multiply. Yep, cosine times cotangent. Chris, you got it?
Is that cut off?
Yeah, cosine times cotangent over on the right. This is one where I do a little bit on both sides to make them match again. Got it. They're like little puzzles. Check in with each other, make sure you guys are both getting there. Yeah, Tyler? Congrats.
It's right. It was just over.
Got it? Okay.
Figured out left side of that right.
Okay. I think the right side's easier than the left side. Yeah.
I thought I had the concept.
Okay, that's good. All right, guys, let me go through it. So cosecant, what should I rewrite that as? And then I'll put my sine over 1. I need a common denominator there. Okay, so did we get 1 minus sine squared theta in the direction? That is actually cosine squared. Now again, you could keep working there, and that will absolutely turn into the right side. Or I'm going to switch over to the right side. How could I rewrite cotangent?
Cosine theta. Oh, yeah, cosine over 6.
And when I multiply, what do I get? And you're done.
So can you just go back to front?
Yep. We wrote that in the...
How did I not remember this?
I don't know. It's in your quotient identities. All right, guys, questions? Not today, but we will within the next few days. Yes. That's a Pythagorean identity. Yep. Knowing those and being able to use those substitutions makes things much easier. Okay, I'm going to give you your homework and give you the rest of the time to work on that. It is paper homework for the first, like, 6.1, and then after that, it'll be back to Delta. I wrote on the top for you just
No.
Being in high I don't even have to go to the bathroom.
No, I just need to take a walk. I'm not hella distracted. I have to take my learners for it. Start studying until last night.
Super Mitchell?
I don't know if it's science.
Yeah.
See, he took advantage of it, Ricky.
Yep, good.
Missed your chance. God, it's on my head.
It's okay, it has to be done on the paper.
Wait, that was number one. Are you kidding me?
Oh, yeah.
Bro, he's huge or not. He's huge or not. That's green. Oh! Yeah, he said fine.
Alright guys, a little more math, a little less that.
Velocity.
Wait a second.
We got still on the second last one.
We're using
Just let me know when you want me to scroll down, okay?
Say,